Let's wrap this particular section up with an example, kind of a famous example known as Gabriel's horn. Now here's the idea. We have a solid form revolving about the x-axis, the unbounded region between the x-axis, and it's given by f of x equals 1 over x. Now, we've seen this before. So what we end up having here, specifically, we'll go from 1 to infinity. And I'm going to revolve this about the x-axis, so I end up with this horn-looking thing. But of course, asymptotically goes to 0, so it's really an infinitely long horn. Now, there's actually two questions I want to ask about this. Number one, I want to find out the volume of this horn. If I were to actually fill this up, calculate the volume from a volume of revolution, and I want to find out how much volume is actually in there. And then the other thing I want to do is find out how much surface area is actually outside this horn. So for the volume, I need to integrate, and actually there's a typo here. There should be a pi right there. This should be volume is equal to pi times the integral from 1 to infinity. That's pi r squared, so it's 1 over x quantity squared dx. Now, it's a previous theorem. This is a situation, this is 1 over x squared, so it's of the form 1 over x to the p, where p is greater than 1. So from that theorem, we know that it's going to be 1 over 2 minus 1 times pi, which actually gives me a volume of pi. Or you can integrate this, because we already did once. This is 1 over x squared. This is actually an earlier example. And this integral was 1, so this could be 1 times pi. So I know that the volume inside this horn is actually going to be pi. So what's the surface area? The surface area is equal to 2 pi times the integral from 1 to infinity of f of x times the square root of 1 plus f prime of x squared. It's the function times this piece right here is actually the arc length, if you recognize that. So let's go ahead and do that. So I'm going to say the surface area is equal to 2 pi times the integral from 1 to infinity of f of x is 1 over x. Then I have the square root of 1 plus, I need the derivative of 1 over x. That's going to be a negative 1 over x squared, dx. And I'm going to fit around doing some algebra here for a while. See, this is just equal to 2 pi times the integral from 1 to infinity of 1 over x times the square root of, this is going to be 1 over x to the fourth. So if I actually complete this operation of addition, I'll end up with x to the fourth plus 1 over x to the fourth dx. Now obviously this x to the fourth in the bottom I can take out as an x squared. So this is 2 pi times the integral from 1 to infinity of 1 over x cubed. It's 1 over x times 1 over x squared times the square root of x to the fourth plus 1 dx. Now, I need to integrate this thing, and looking at it, straight u substitution is not going to help me. This is going to get a little bit messy. But notice here that square root of x to the fourth plus 1, that's going to be just a little bit bigger than x squared. So I'm going to say note, square root of x to the fourth plus 1 is actually greater than x squared. So if I substitute x squared in there, I'll end up with the integral, or 2 pi times the integral from 1 to infinity of x squared over x cubed dx. And I know whatever this is, it's going to be smaller than what it would be if I integrated with this function, because square root of x squared, this is a plus right here, plus 1, x to the fourth plus 1 is a little bit bigger than x squared. But that cancels, that just becomes x. So this is 2 pi times the integral from 1 to infinity of 1 over x dx. And this is infinite, because the integral from 1 to infinity, 1 over x, using that theorem from before, p equals 1, and we actually looked at this interval. This is infinite. This is divergent. So if this is divergent, and this is actually smaller than what I was trying to integrate, then what I was trying to integrate was divergent. Therefore, the surface area is divergent. So what I have is a infinite amount of surface required in order to hold a volume of pi, and we don't have units on this, pi cubic something. I don't know, this is inches, yards, light years, whatever. So I have a pi cubic something in here, but I require an infinite amount of surface area around this thing in order to hold that volume. Think about it. It's kind of cool.